In this section, we're going to look at a sample C program and identify how it's structured and walk through the vulnerabilities of the application and then exploit the application. So let's go ahead and take a look here. We have a BufferOverflow.c program. We'll go ahead and open that up with Nano. Okay, so we've got our standard IO includes and string includes for C. And in our main function, you can see that we've set up a variable, we're really an array of type character. And we've set a length of the array to 15. Okay, so we've also set another variable, which is the pass variable of type integer, to the value of 0. So in this program, what we're going to do is prompt the user via the print function to enter a password. And you can see it'll use the gets function. And so we'll do a comparison, a string comparison. And we are going to compare the buffer, contents of the buffer, to the password, which I've hard-coded here as being web of security. And if they don't match, then we'll say that's not the right password. So go back, give them an option to put in the correct password, and then we'll set it to 1, and then give them root privileges. So really what we're trying to illustrate in this little sample C program is what happens when the array is overloaded. Okay, so now the gets function is admittedly a deprecated function within C, and the compiler is going to give you errors, and that's fine. But it allows us to go in and kind of illustrate what happens when we overflow a buffer. All right, so let's go ahead and close this out. And I have already compiled this and run the compiled program. All right, so our program is asking us for a password. I'm going to go ahead and enter the correct one as it was designed, just so we can make sure that it's functioning properly. Okay, great. It said that we have root privileges, which really doesn't mean anything in the context of this program. But what happens if we run this, and remember, this array of 15 characters is what's the construct that's been set up to accept our input. Now what happens if we put in more than 15 characters and press enter? Well, so the runtime caught it, right? But it killed the program. So it detected that we were trying to smash the stack, and we indeed were trying to smash the stack. And the program was terminated. So this is an example of a poorly written program from a buffer overflow standpoint. When it comes to buffer overflows, what we're looking for in best practices, is to make sure that we're doing input validation and parameter checking. Now, in C, that's extremely important. In some languages, it's not quite as important that are type safe. For instance, Java handles these things automatically.